Hello, welcome to the next video. Now I'm going to continue on with some applications of electric fields. Now you might be wondering, why am I doing all these applications? It's so that we can put the physics that we're actually doing into a real world context. And so all these examples are using electric fields somehow, and we might well be asking you questions which may relate to these applications. So it helps you understand the questions that we're asking you, but it also helps you realize that physics is everywhere. And although you might think electric fields is a bit esoteric, it's actually everywhere. Everything that we use more than likely has some physics related to it, and electric fields is a field of physics that is being used all over the place. And so that's why I'm doing this. And the last video we sort of went a bit long, so I cut it off, so we'll just have a quick one here, I think. Just doing a couple of last applications. And there are other applications as well, apart from these, but these are some I've just found some information about. So photocopiers, things that we use, very much dependent on the use of electric fields and electrostatics, and this is the basic principle of a photocopier. Now different machines do different processes, but they're still all relying on the distribution of charges and the development of electric fields and things like that. And so you put your document in. Document is projected onto a charging plate. Now that could be a plate or a drum. Most modern photocopiers now use a drum. When the light falls on the plate, charge leaks away, so there's an interaction between photons and charge, which is a little bit outside of our course, but it's quite interesting how that works. The negatively charged black toner particles are then dusted onto the plate, and so the toner sticks where it's being charged, and then paper's put on it, and the toner goes onto the paper, and then it's heated to melt the little bit of wax that's in the toner, so it sticks to the paper. That's why photocopiers come out warm. I've got here somewhere a little video. Here we go. I'll bring this across. Have to use my mouse. And this is pretty old, but it's instructive, so just have a quick listen to this.
Xerography is based on the principle that a certain material can retain an electrostatic imprint of a brightly lit image. When a document is placed in a copier, a bright light is bounced off the paper, through a lens, and onto a specially coated drum. The coating becomes electrostatically charged with a mirror image of the document. As the drum rotates, the fine black particles that make up the ink, called toner, are attracted to the charged areas on the drum, the same areas that would be the print on the paper. As copy paper is rolled over the drum, a heat roller fuses the toner from the drum and onto the paper, reproducing the original image.
Fantastic.
Zero.
Oops, nearly went again. Alright, so usually at this point I say just go next door and pull the photocopier apart and have a look at how it works. Let's not do that. So that's that video there. Now the next thing we're going to talk about is what's called SED screens. Are they going to be the next big thing? Most of this stuff I found out about a couple of years ago, and basically they're going to be television screens that may replace LCD and plasma monitors. Well, at the moment we can all go out and buy LCD or plasma TVs. Pretty much hard to buy a old cathode ray tube. I think there's one factory somewhere in the world still making them, because they have some specialty needs. But are LCD and plasma TVs the future? Well, maybe not, because as with most things, technology, people are approaching things from different angles, and the SED may be just about coming out in the next year or two. And basically what they've done is they've taken the cathode ray TV and shrunk that technology down into something that basically each pixel is a cathode ray tube. So you have an electron gun, your phosphorus screen, exactly the same as we were thinking when we were looking at cathode ray tube and electron guns. So on a TV where you have those many pixels, you'd have 6.2 million electron guns firing away, making the image. And these are early prototypes. You can see that they're still a bit chunky, but the real selling point is if you compare the blacks. This might be a little bit, I think LCDs have improved a little bit, but LCD and plasmas cannot show true black. There's always a residual amount of light, so what they call black is actually grey, and you can see it when your TV's in a completely darkened room and a movie or show goes into a black screen. It's not as black as it could be, whereas the SEDs would have true black. They would not emit any light whatsoever from their screens, and that's a selling point that might help them get developed. And so if we have a closer look at it, each subpixel is a little electron gun that has a voltage in it, so we're relying on electric fields to get those electrons to hit the phosphorus. And if we look at it, now this is the cathode ray tube. You have your electron gun, the beams go out, get bent by deflecting fields and go across the screen. In the SED, each of these pixels is a gun, and if we blow this up down to here, we can see that you've got the voltage between the two glass plates. You've got an electron emitter, and then each of these will fire only when a certain coloured pixel is needed, and so the electron goes across, hits the phosphorus, and you get the colour, and that's how they work. So these guys, I think they were just being shown at the last technology expo, and haven't heard anything more about them. So whether or not they're ever going to eventuate, sometimes technology gets developed to a high level, but then nothing ever happens to it because of commercial realities. So in the next video we're going to talk about Faraday cages. Alright, cheerio!